studied the thermodynamics before, right? In thermodynamics, there's a conservation of energy. So it's pretty much the same. Just saying that if you have current coming to the node, it must be the same as the current leaving the node. Okay. So let me do a very simple example. Say you have a node right here. The voltage source. And then let's say this is 2 ohm. This is 4 ohm. This is 3 ohm. Right? And let's say this current going here is I1, I2, and I3. So we want to find the currents I1, I2, and I3. Okay? Now what is the simplest way and the quickest way to do this problem? This is a very simple one, huh? You should know. If you don't know, then you are not catching up with the class.
Volt divided by resistance?
Yeah. The simplest way to solve this problem is to use the Ohm's law. Yeah? So what you have is between these two nodes, okay, this is a single node, right? That's a single node. So between these two nodes, there's a voltage of 10 volts. Right? So by simply using the Ohm's law, you know that I1 is equal to the voltage across this, which is 10 volt divided by 2 ohm. Correct? So you get 5N. I2, by the same concept, is 10 volt divided by 4 ohm, so that gives you 2.5N. And I3 is 10 volt divided by 8 ohm, so that gives you 1.25N. Right? Okay, now, another way to solve this problem is to use the KCL. Okay. Now, when you have a voltage source, as I mentioned last time, and you should remember this, the current that is generated by the voltage source always go from the negative polarity to the positive polarity. Okay, so therefore, this I call I. So therefore, if you look at this single node right here, okay, this node, I can apply the KCL. Right? KCL saying the currents entering and leaving must be equal to each other. Okay, so what you can do is you can say the current leaving and entering the node is plus, and the currents leaving the node is negative. Okay, so therefore, I plus minus I1 minus I2 minus I3 must equal to
0.
0. Huh? So that is basically the kernel. So if I want to find I, then I is equal to I1 plus I2 plus I3, and then from this values, you know I is equal to what? 5 plus 2.5 plus 1.25. the KCL, we can also derive a rule called the current divider rule. Okay, so let's say you have two branches. R1, R2. Yeah? And let's say you have a current here. That's called I. Let's say this current is I1, this is I2. Right? So from the KVL, from the KCL, you know that I must equal to I1 plus I2. Yes? This is equal. Correct? Then the current in the individual branch can be written in terms of I by what we call the current divider rule. Okay, so I1, here are the formulas. Okay? I1 equal to I times R1 plus R2. That's on the denominator. It's the sum of the two. And then on the numerator, it is the resistance of the other branch, which is R2. Right? So you see, we are looking for the current going through R1. So when you use the formula, this number on the top should be the resistance in the other branch. The same concept, I2 equal to I times R1 plus R2, and then the other branch, which is R1. Okay, I want to put a note here. This rule applies only to a circuit with two branches. Okay, so this is two branches, right? It does not apply to a circuit that has more than two branches. So why don't we do an example again? Say, again, it will be very simple. This is a current source. And then let's say I have three resistors. 1 ohm, 2 ohm, 4 ohm. And this is 10 amp, right? Okay, and I want to find out what are the current, I1, I2, I3. Yes? I1, I2, 3. Okay, first of all, from the KCL, you know that 10 amp must equal to I1 plus I2 plus I3. Yes? So this is KCL. Okay. Then to find the individual values of I1, I2, and I3, we can apply the current divider rule. But before we do that, I need to make this into two branches. right? Because this circuit has 3 branches. Has 3 branches of resistors. In order to use the current divider rule, you have to make it a 2 branch. Okay? So there are many different ways you can do this problem. Okay? You can say, oh, combine these 2 into 1, or I can combine these 2 into 1. Huh? So either way is okay. So let's say I want to keep the 1 ohm, right? Okay, then I combine these 2, so 2 ohm and 4 ohm. I don't have the calculator. What is it? What is 2 ohm and 4 ohm in parallel? So it's 2 in parallel with 4 is 2 to 1. 1 over half plus 1 over 4, right? That's the formula. And so, what is it?
4/3.
Huh?
1.33.
0.75? Yeah? Okay. So this is 0.75, right? So therefore, this is the combination of that. Yes?
Isn't it 4/3? Not,
1.2.
it should be 1.33.
Oh, 4/3. Okay. Okay. Yeah? Okay. Now we have a circuit with 2 branches of resistors. So now I can start to apply the current divider rule. So this is 10 amps, correct? Okay, so I'm going to call this is still I1, but this is not I2 or I3 anymore, right? What is it?
2, 3.
This becomes what? I2 plus I3. Yes?
Yes.
Why? Because if I combine these 2, then the currents must be added. Yeah? Okay. And then we call this I prime, to make it easier. Now, so with the current divider rule, I1 is equal to this current, right?
Yeah.
Actually, this current gets divided into 2, right? That's why it's called the current divider rule. You know, it's like a river, right? It gets split into 2 different branches. So I1 is a portion of that, yes? This current must be smaller than that, right?
Yeah.
Okay. So it's equal to 10 amp times, according to the current divider rule, is the sum of the 2, right? 1 plus 4/3, and then the top one is what? 4/3, right? When you are looking for the current here, the resistor on the top must be the resistance from the other branch. So you get the number, and I prime, this current, must be equal to 10 amp times 1 plus 4/3, and then 1 on the top. Yes? So now we have found I1. That was one of the problems. But now, next we have to try to find I2 and I3. Right? So now we have 2 ohm, 4 ohm. This is I2. This is I3. Right? Okay. Then this current entering this 2, what is that?
I5.
This is I prime.
Prime.
Correct? Is it I prime? Because I prime is the current or the combination of the 2 ohm and the 4 ohm. Huh? So therefore, your I2, again, you can use the current divider rule. So therefore, I2 is equal to what? I prime times, I times the main current, right? Okay, so it's 2 ohm plus 1 ohm, then 1 ohm on the top, right? And then I3 is equal to I prime, 2 ohm plus 1 ohm, and 2 ohm on top.
Would it be 4 ohms at the bottom?
Yeah, on I2.
Oh, yeah, I'm sorry.
And then 4 on top.
4 on top, yeah. Okay, now we're going to do several problems that has both the parallel and the series connected together. So that means the circuit becomes more complex. So now we're going to look at circuit with series and parallel combination. Let's say you want to find, there are many different things to find. Let's say you want to find I2, this is I1. Let's say you want to find the voltage here, V1. Okay, so find I1, I2, and V1. Okay. Normally, when we have a node on the bottom of the circuit, that node is normally called the grounding node, ground. Okay, so I will use this symbol as the ground. When we have a ground, that means the potential here is zero, right? So voltage is equal to 0. And then all the voltages in the circuit will be referenced to that ground. Okay? For example, if I'm looking for this voltage at this node, then that will be the voltage at this node to the ground. Huh? Well, how do you solve this problem? There are many different ways. One way is the following. Okay, you can try to make a single equivalent circuit, a single equivalent resistance for that box, and then you can find the current. So there's a current, right? It's called I. Once you find a current, then you can try to use the current divider rule to find the currents of I1 and I2. Okay, so let's do that. Huh? And then I will use a second approach later. So, what is the single equivalent resistance on in the box? you need to look at, understand that this is in parallel, correct? Okay, so you have 10K, right? You have this 2 in parallel is what? 3K in parallel with 6K is 2K, right? And then you have a 4K, and then you have 8K. Correct?
Yes.
So this is the box, huh? Okay, now, these 2 are in series, right? So 12K. These 2 also in series, 12K. Yes? So 12K and 12K are in parallel, yes? So now you have a single resistance of 6K. So therefore, that is the equivalent circuit, equivalent resistance of the box. Okay, so therefore, the circuit becomes 6K, 24 volt, and this is the current I, yes? And that's the box. So the current becomes very obvious, is 24 volt divided by 6K, right? How do I get this? Well, voltage across here is 24, right? The voltage here is the same as the voltage here, huh? Yeah, 24. I never mentioned this, but when you have a parallel combination, the voltage is the same, huh? Across the node. Got it? Let's say you have several different branches, huh? Okay, let's say this is your V. Okay, so this is a parallel combination, huh? So the voltage on the parallel is always the same, huh? VZV. Yes? Now, if you have series combination, then what will be the same? Current. This time the current will be the same, huh? The current going through the series combination will be the same, huh? Same current. Now, this is fairly obvious, so I'm not really emphasize.
Yeah. We're making circuits every day.
Okay, now you have I equal to 4M. Oh, not 4M, what is it? 4 times 10 to the minus 3M. Yes? Because this is 6K. K is 1,000, right? So, and we normally call this 4 mini-M. Okay, so M represent 10 to the minus 3. Huh? And sometimes we use micro M. Micro is what? 10 to the minus 6 M. Okay? Okay, now, what do you do next? Now you can use the current divided the rule. Huh? So now if I come back to here, this current is our I, right? Yes?
Yes.
So it's equal to 4 mini-M. Okay, now I have 2 branches. Each branch has a 12K resistance. So therefore, this current we call I1, this current we call I2, right? So you can use the current divider rule. I1 equal to I times one branch, 12K, the other branch, 12K, and then 12K on top. So basically, you get half. You get half the total current, so 2 mini-M. And I2 is the same concept. The total current I times 12K plus 12K, and then 12K on top, so it's 2 mini-M. So I simply use the current divider rule, that's all, right? Because I have two branches, and I have a main current coming in. Okay, the last one, the voltage here. Is that the same voltage as the voltage across 2K? Huh? Is it the same? Maybe you don't see it.
Because we're not engineers. Yeah, it is.
It is the same, right? Because if you make the two combinations into one, like this one, the voltage across this one should be the same as the voltage on each one of the, yeah.
Does the ground have any effect on the 6K? Voltage on the 6K?
No, the ground means that the voltage here, okay, on this node, is 0, that's all. Yeah, there's nothing to use. Well, if you don't see that, okay, you don't see this, we can try to find out what is the current going through here. Can I? Let me call this I, how do you call it? I3, can I? I3. So once I find the current I3, and I multiply to 3K, that gives me the voltage, right? Okay, so how do you find I3? I know I1, yes? So I can use one more time the current divider rule. Right? Okay, so I hope you are following my analysis here. So basically you have two branches down here. Huh? You have 3K, you have 6K, correct? And then from the top, you get I1, which is
2 milliamps.
2 milliamps. So we are looking for the voltage here, huh? V1. Okay, and this is what we call the I3. So from the current divider rule, I3 is equal to I1 times what? 3K plus 6K, right? And then what's on top? 6K, yes?
Yes.
Because if you are looking for the current in this branch, then this must be the resistance in the other branch. Huh? So 2 milliamp times 9K divided by 6K. So it's 12 divided by 9. I don't know what that is, okay? Huh? 1 point something, huh? 2.5, yeah?
1.3.
1.3? Well, at least I was close. Huh? Okay. Then, what is V1? Then you can use the Ohm's law, right? V1 is equal to I3 times 3K. So it's equal to 3.9 volts. Yes? Milliamp times mini times K cancel each other. Huh? This is 10 to the minus 3, this is 10 to the 3. 3.9 volts. Okay, any questions about this? Did I go too fast? Yes. I did?
Yes.
Okay, I'm going to do more examples. Right? Hopefully, by the end. Huh? V1 is the voltage across the 3K, right? So that is equal to the current times 3K, Ohm's law. Okay. So, and how do you find I3? We can find I3 using the current divider rule, because you have a main current. Basically, you have a main current here, and the current gets split into two branches. Okay? So you can use the current divider rule and you can find I3. And this is the formula for the current divider rule. So once you found I3, then you multiply to 3K, they give you the voltage.
Would that be a millivolts or just a regular?
Huh?
For that, because it's milliamps, would that be a smaller voltage, or would it be just regular voltage?
No, because this is a milliamp. Huh? Let me go back. Okay, so this is 1.3 times 10 to the minus 3, right? Milliamp times 3K, which is 0, 0, 0. Yes? So that cancels, so you get 3.9 volt. Yeah? Exercise? There's nothing else. You had algebra, right? Did you have calculus before? No calculus.
Intro to calculus.
No differential equations.
No. Or IT.
Okay. You should be okay for all the chapter before chapter 4.
This is bullshit.
Because once we get into chapter 5, then we started to have the differential equations. And I don't know how you learn that material without having the background of differential equations.
You're supposed to teach it.
Not prerequisite?
No.
Okay, we find a way around it, okay?
I hope so. I actually had calculus, but it's 15 years ago. You don't need it for IT. You just intro to calculus. What's that, like trig? Yeah.
Okay, I'm going to do 2 more examples. We have about 15 minutes left. Okay? You have to study, you have to go home and study, okay? You cannot just come here and listen and then just go on and play something else.
The thing I know, I think so far, this is just a refresher for me. So. So we're going to find everything that were labeled on the circuit. Huh? The current, I1, I2, I3, I4, I5, and also we're going to find the voltage V sub C across the 3 ohm, 3K resistance. Huh? Okay, again, the best way to solve this is to try to find the equivalent resistance in that box. Yeah? Okay. So if you go from, because you are looking for the resistance from this 2 node, right? This 2 node. So you should go from the opposite side, from the right hand side, and then gradually arrive at the node. these two in series? Yes?
Okay.
Yeah. Get, let's say, the mark here, okay? That's the terminals. And you have 6K, you have 3K, you have 4K, right? So far, I have not changed anything. Okay, now I'm going to combine these two and then make it 12K, correct?
You still need that 9K, don't you?
Huh?
Is that outside?
Outside the box? Oh, okay, I can put that. That's the outside the box, yeah? That's 9K, yes? So we are talking about the box right here, huh? Yes? Okay. Then these two are in parallel. Okay, so 12K, 4K in parallel will be 3K. Yes? Now you should do calculation yourself, okay? You should. All right, so this is 6K, 3K, 3K. And then we have a 4K. No. These two have become 3K, huh? Correct? Okay, then 3 and 3 in series, right? So that becomes 6K, 6K, right? So that's the Alright, so finally we have arrived at a single equivalent resistor that has a value of 3K, yes? 6 and 6, 3. Okay, so that's the box, yes? Okay, so let me put the component to the left of the box. What do I have here? I have a 9K, yes? And then, what do I have? I have a voltage source of 12 volt. Is that correct?
Choose plus and minus upside.
Right?
Plus and minus is switch.
Oh, upside.
Yeah, I always remember.
Right? Okay. Now we can try to find this current, which is labeled as 1I1. Okay, so how do you find that current? You have a single loop, so I can use the Kirchhoff voltage law, right? So I'm going to put the equation down here, okay? I don't want to erase that because I need it later. Okay, so based on the Kirchhoff voltage law, all the voltage rises and the drops equal to the sum of that equal to 0, right? Okay, so if I go from this point, I follow the current direction. So I will get a plus minus, right? A plus minus. So if you go in this direction, you have, first you see a voltage drop. Yes? And what is that voltage? It's I1 times 9K, correct? According to the Ohm's law. Minus, because it's a voltage drop, yes? And then you see a second voltage drop on the 3K. So minus I1 times 3K. And then you go in this direction, right? Now you see a voltage rise. It's a voltage of what? 12 volts. And that has to be equal to 0, yes?
Yes.
That is the Kirchhoff voltage law. So I go around a closed loop, right? And I add up the voltage drops and the voltage rise. And the sum of that must be equal to 0. Okay, now you have one equation and one unknown. And that's good news. right? That means you can solve for that unknown. So what is I1 now? I1 is equal to 12 volt divided by what?
Negative
12K.
27.
It's not negative anymore because you move this on the other side to positive, right? Okay, so it's what?
One of them stays
It's
negative.
1 milliamp, correct? Okay, now from this step to this step, that is just algebra, huh? I don't supposed to teach you algebra, right? All right. So now, if you go back to here, where's I1? I1 is here, right? And then if I come here, this is I1, correct? And then where's I1? This is I1. Yes?
Yes.
And this is I1. Yes? Okay. Now I can try to find out what is the current going through this and that. I'm going to call this I prime, this is I double prime. Right? Okay, so I'm going to use the current divider rule. I prime is equal to I1 times what? 6K plus 6K and 6K on top. This is the current divider rule. Right? So, it becomes what? 0.5 milliamp. I double prime is I1 times the same thing. 0.5 milliamp. Now, I prime here is the same as I2. Excellent. Yeah. So this is I2. So I prime is actually the same as I2. Right? So now we have I2 here. What about this current right here? This current is what? I double prime, correct? This is I prime. Okay, if I come back to here, where's my I double prime? Yes, yes. This is I double prime. Yes? Now I can try to find out what is the current going through here and here. Because I know the main current and this is a branch of two resistors. Okay, I need to find new notations. Huh? What do I call? I triple prime. Okay. Okay, so if I come back here, I triple prime is equal to I double prime times 4K plus 12K and then 12K on top. Yes? And that, I don't know what that is. You have to do equations. Right? So this is what? This is 0.5 milliamp times 16K, 12K, right? So what is it? Point what? 0.3? 75.
No, he's double changing. I double prime going down to 16. Right?
Okay, then what is that current in the original circuit? Huh? I4, that's right. So that is equal to I4. Yeah? Okay, now, once you know I4, you know what else do you know? You know I2, then you can keep on going and try to find out I5, correct? It's the same concept, right? And once you have found I5, then VC is equal to what? VC is equal to I5 times 3K. Okay? So that will be the value for the voltage on